used traditionally and how we now do that at LinkedIn. So LinkedIn is a major Java shop, really. So we have on the order of 6,000 Java applications. We have hundreds, thousands of hosts running these applications. So there are, lots of instances of each app, and inevitably at this scale, some apps will run into problems sooner or later. Some of these problems are memory problems, and some memory problems are best diagnosed using heap dumps. So what is a JVM heap dump? It's actually kind of, in a nutshell, it's entire heap memory snapshot that is contained in a binary file. So it stores content of every object and all the references between objects. Also, as auxiliary information, it contains thread stacks, which at times can be pretty useful. So the format of this heap dump file is portable, in theory at least. So in practice for hotspot JVM, it is indeed portable. It's the same regardless of which OS it was generated on. Then sort of in theory, it's supported by other JVMs too. Well, some JVMs like IBM actually have their own format. Some others may have this hprof. Why and when are heap dumps really useful? They are useful because they contain information, first of all, about where memory goes. So, for example, you can look into the heap dump, or rather, you can use some tool to look into the heap dump and discover that, for example, strings take like 70% of the heap. So that might, in some situations, be a relation. You may not have expected it. Then, even more importantly, certain tools to some degree allow you to see where memory is possibly wasted. So here is an example of when I analyzed one of the very first heap dumps in my own practice. I discovered that of the many strings contained in these heap dumps, nearly 50% were copies of the same SQL query. So that was really a bug in this application. For some reason, first of all, they issued the same query repeatedly, and then for some reason, they kept this string in memory, so it just flooded and caused an out-of-memory error. So therefore, especially in the case of out-of-memory error or memory leak, heap dumps are really indispensable because they really allow you, in most situations, to immediately see who caused this problem. They are also very useful when your heap usage is just high, so higher than you expected, or higher than it was before. For example, your application ran without any problems with like 10 gigabyte heap, and then after an update, all of a sudden, it started to struggle. So it performs GC frequently. It really looks like it needs more memory now. Why? Okay, take a heap dump now and see where memory goes. Ideally, take a heap dump before and compare them. And even in the situation when it's not obvious or clearly the heap size is big enough, but the application has problems with GC performance, even in these situations, heap dumps may help. So by telling you, for example, where what objects contribute most to the garbage, you can make some interesting conclusions. So now, how to take a heap dump? On your laptop, it will be trivial. You know, if you started an application on your laptop, just use the JK jmap command, jmap pid of this application, and the dump will be on your disk locally. Everything is fine. Unfortunately, it's not so trivial, or may not be trivial at all, on a production host. You will inevitably have to jump through some hoops, intended to actually ensure security. So you will need to get access to this host. You will need to get sufficient OS privileges to run the same jmap command. And so your whole sequence of operations will look like SSH, run jmap command, zip the dump, SCP to your machine or to some other machine, unzip, and finally analyze. So this is really cumbersome and time-consuming. The next step is how do you analyze a heap dump? As I said, these are binary files. They are not human readable. Even if they were human readable, they are huge. They are kind of modern Java heaps, typically measured in gigabytes. So you have no hope, of course, to read this kind of by eyeballing. So you need some tool that will process this dump and that will give you the most essential information about it. So fortunately, tools are available, both free and commercial. So probably the most famous free tool is EclipseMet. Also, there are YourKit and JProfiler profilers that also include the function of heap dump analysis. So in principle, yeah, the tools are there. However, there are certain issues with them. The main one is, well, it may or may not be an issue depending on the situation, but they are visual tools. So you need a machine with screen to analyze a heap dump. And if a heap dump is just, okay, 1 gigabyte, analyze it on your laptop will probably have much more RAM than that, so no problem. But what if your heap dump is taken on a production machine with 100 gigabytes of RAM and the dump itself is 100 gigabytes? How do you find a machine with such a big RAM, so much memory, and a screen attached? You will probably need to jump through some hoops once again, and that can be difficult. And also, visual tools are great, except that only one person can use such a tool at a time, essentially. So you open it, you are looking at it, but if you want to share some results, the best thing you can do is you can just share some screenshots with others. That's the best. Okay, so now let's explain how we solve these two problems of taking a heap dump and of analyzing it, how we solved that at LinkedIn. So to take a heap dump, to avoid, save users from jumping through all these hoops, we reused a system which fortunately already existed before, which is called homegrown distributed system called on-demand profiling. So it was initially designed for taking CPU or memory allocation profile on any host, and we reused it for taking heap dumps. So this is a distributed system which runs an agent on each host. So basically, therefore, you can, instead of a manual SSH or whatever, you can just send the command, do something on that specific host. And then this system obviously has some UI, web UI, and it manages the central storage for these profiles and for heap dumps. Since heap dumps require, it's not enough to just take them, but you also need to run a tool to process it. This on-demand profiling was augmented with an automated pipeline, which performs all these cumbersome operations that I've just described automatically. So it tells an agent to run JMap on the given host. It compresses the generated heap dump, transfers it to one of the dedicated analysis machines, uncompresses it, processes it on this machine, and finally saves the results in the central storage. After that, these heap dump processing results are available to anyone through the UI of this ODP. And now probably the most important part of this story, how we analyze heap dumps, how we overcome that problem that I mentioned before of visual tools that only run for as long as the user runs them. So for that purpose, we use a relatively new tool called JXRay, or rather now Microsoft JXRay. So this is my own project, which I started to use at LinkedIn when I joined it in 2019, and then it was finally licensed to Microsoft in 2022. So this tool uses a different approach to heap dump analysis, where the tool runs just once, processes the dump, and generates an HTML report. So single HTML file containing most essential information, the most essential information about this heap dump. So it looks for tens of anti-patterns upfront. So it looks for all possible kind of problems or potential issues, defects in the heap dumps, analyzes each of them, and in some situations even gives some advice on how to change the code to address some of these problems, which are most well studied or most easy to fix. And so see the JXRay website for more details. Sorry. One other important sort of unintended advantage of this tool is that security comes naturally. So heap dumps are really a snapshot of the entire JVM memory, which may contain some sensitive information. It may contain some very personal details about some users. It may contain some credit card numbers, whatever. So for certain applications, getting access to the entire heap dump and extracting certain data from it may really be beneficial for kind of bad actors. Fortunately, with JXRay, this problem is virtually non-existent, because when it processes the dump, it saves only samples of some objects. So the chance that any significant amount of any sensitive information will leak into that JXRay report is very, very low. So yeah, we kind of, when I worked on JXRay, when I designed this tool, the way I designed it, I didn't think about this problem, but that came as a very pleasant addition. All right, so in more details, what these JXRay reports look like. So for every heap dump, we generate a single HTML file, which, however, can be pretty big. It's usually between 6 and 10 megabytes. And this HTML file is sort of semi-interactive. It uses even some JavaScript internally. So it's just not like a web page, not like some text. You really can expand or compact some sections of this file. You can drill down. So yeah, probably a demo would be worthwhile, but we don't have time for that. However, some heap dump analysis JXRay report files are available on the JXRay website, so you are welcome to check them out. This HTML file, at the high level, it consists of the two main sections. So the first is the overview of the heap contents, such as where memory goes by class, where memory goes by GC root, thread stacks. So this allows you to really get some idea of, indeed, kind of what are the main consumers of memory in your application. But then there is this second top-level section of where memory is really, where it may be potentially really wasted, or what may cause performance degradation. So in this category, as I said before, we analyze tens of different anti-patterns in the following broad categories. One broad category is duplicate objects. So it may turn out, as I say, that, for example, you may have hundreds of copies of the same very long SQL query, or there can be copies of some arrays, buffers, records, whatever. There may also be underutilized or empty data structures. This is especially common with buffers, like you allocate or more like third-party library allocate 1 megabyte buffers, but never uses more than a few kilobytes in the beginning of this buffer. So in this case, by just tuning that library like native to use smaller buffers may immediately save you quite a lot of memory. And finally, there is another category of various miscellaneous anti-patterns, such as box numbers, which are an interesting feature in Java, which is generally useful, but can be a problem if there are too many of them. Finalization, which is yet another Java feature, homologous objects, and all sorts of other Java-specific issues. Here are some samples of JXRay reports. So this is what you see when you open such a report for some specific heap dump. This is what you see first, the top of this HTML page. So in this case, the tool is happy to tell you that it found a couple of problems that are easy or relatively easy to fix. So this one, underutilized netty buffers, is very much what I've just mentioned a couple of minutes ago. So really a third-party library called netty creates some internal buffers, and oftentimes they are too big. So by just changing some system property, if you click on this triangle, you will see a more detailed explanation on how to fix this issue. This problem, the next problem, is more complex, but, well, whatever. Sometimes it's still possible to address it. And then there are other problems for which there are no kind of off-the-shelf solutions, but which nevertheless cause enough memory waste and therefore are worth looking at. Again, for each of these problems, you can click on this triangle to see some details, and you can kind of go down this report. You can drill down and see, for example, where these underutilized arrays are coming from, where this duplicate data is coming from, and so on and so forth. Here is, yes, one example of such a drill down. So for a potential memory leak, the tool presents the object tree. So this is a garbage collection GC root, a finalizer object, and then we see that in this case, quite a lot of memory, 1/5, 22%, is taken by objects awaiting finalization, which is really not a great thing at all. These objects should have been garbage collected long ago, but for some reason they are still waiting. Probably, maybe because the finalization code does a lot of things and therefore slow. Probably for some other reason. But anyway, so here you have a very strong clue. Open this, open this file. Look at why does it need finalization at all, kind of, and see how to improve it to address this problem. Another example is taken from one concrete application and showing duplicate strings. So in this case, the percentage of waste due to duplicate strings is not that high, 8%, but this is an application running with a really big heap. So in absolute terms, it's quite a lot. It's 2 gigabytes. So you could potentially save 2 gigabytes of memory and also very likely improve GC performance as well if you managed to get rid to what is called deduplicate all of these string copies. So in this case, we see that there are 36 copies of this string and 30 copies of this string, and so on and so forth. And we also see, I've already kind of drilled down a bit, we also see that where the strings are coming from. So to me, this kind of sequence of object references and class names, they don't really tell a lot. All I can say is that probably this is some sort of local cache or whatever, so some sort of relatively permanent storage for these objects. But for owners of this application, that will certainly tell much more. So they can decide whether they need to keep these objects for that much time, or if they really need to do it, they can apply one or another method of object deduplication. That's on its own an interesting topic. And at LinkedIn, we managed to solve this problem in kind of an innovative way by implementing some code that really allows you to deduplicate objects with the minimum kind of minimum overhead. So yeah, these are some examples. There are many more of them. Over time, we managed to fix hundreds of applications at LinkedIn through through JXRay analysis of their heap dumps. And once the ODP pipeline was established, kind of getting and analyzing heap dumps, that reduced from hours as it was before to literally minutes. So therefore, at this time, really any engineer at LinkedIn, first of all, can take a heap dump of their application at any time on any host by just opening a web page, entering this information, and pressing a button. No SSH, no requesting permission, no asking SREs for help, no searching for suitably big machine to analyze a big dump, and so on and so forth. Everything is done automatically, and literally within minutes, they will receive JXRay analysis. On out-of-memory error, a heap dump is generated automatically. So if your application crashed at midnight because it ran out of memory, then in the morning you will see the heap dump analysis, and you will be very likely you will know what to do again very quickly. Speaking of these JXRay reports, a big advantage is that they can be shared with others. So oftentimes, honestly, most engineers don't really have much expertise in heap dump analysis. So fortunately for them, memory problems occur not that often, maybe for an average application, maybe once in a year, maybe once a half a year, maybe never even. So it's understandable that many engineers actually don't have much expertise in analyzing the heap dump, but the good thing is that they can now share it with those who have expertise, or with us, the Java team. And we can, by just glancing at this report, we can often tell them right away that just go fix this or fix that. Still, even for non-experts, the learning curve is relatively easy because, well, the JXRay was designed from that perspective. So really find problems proactively which users may not even know about, and try to present them to users in the most in the simplest possible way, and whenever possible even tell them how to fix it. And other advantages of this approach is that, yeah, as I mentioned, big heap dumps are not an issue. Security is not an issue. So again, exchanging these JXRay reports, sharing them with anybody is not a problem. And yeah, so I think, therefore, at LinkedIn, we now have a pretty good situation in this area. And probably the only significant missing piece at this time is probably some sort of AI analysis of the heap dumps that would replace experts and really, in some situations, explain the users in details what they need to do based on the past experience. Yeah, that would probably be the next step in this area. And that concludes my presentation. Thank you very much.